Hi, today we're going to be looking at Standard 31, surface area and volume of pyramids. And before we do that, we're actually going to take a look at some prisms that we didn't talk about in our last standard. And that is, we're going to take a look at oblique prisms and pyramids. And oblique means that it's not standing straight up, it's slanted. So the prisms that we've done in the past have been standing. If you stood them up on their base, they would stand up straight, making a 90-degree angle with the table or floor that they were sitting on. And they are sort of the tallest that prism could be. So now you want to imagine taking that prism and sort of knocking it over a little bit. It's still sitting on the table. Its bottom is, the top is still parallel to the bottom base, but now it's leaning over. So we're going to take a look at how to find the surface area and how to find the volume of an oblique prism. So to do that, first, surface area. There's no formula for surface area, so we are instead just going to add up all of the sides areas. So for surface area, that's going to equal add up the areas of all of the sides. If we were to try using the surface area formula that we've had in the past, that formula assumes that the prism is standing up straight, and it's not, so it will give us an incorrect surface area. For volume, the formula for that is volume is equal to the area of the base, whatever that base may be, and we use a capital B for that, and H star. And remember that the star means that H is the height of the entire three-dimensional shape. It is not a height for one of the sides or one of the bases or anything like that. It is the height of the shape. So in our picture here, the height can be found right there. I can spot it because it's making a right angle with the base of the shape. All right, let's take a look at example A. If we were to find the surface area, you would just add up the sides of this shape. There are 5 sides, and you would add them together. Let's go ahead and find the volume, since that's the one that's using the formula. To find the volume, we need to first start with the formula, which is volume equals area of the base times height of the shape. That's the appropriate symbols. Then we're going to plug in what we know and solve for what we don't. So in this case, I don't know what the volume is. I'm trying to solve that, so that's going to stay a V. The capital B is area of the base, and while I've not given that, I think I have enough information to find it. So going to the shape over here, this shape is an oblique triangular prism. Notice that the 2 bases, so here's one and here's one, are triangles. I know for sure that those are the bases, not because it's sitting on one of them, because you could always pick up a shape and set it down in a different way. I know it's the base because they are parallel sides from each other, and they're congruent to each other. So you can always spot the bases by looking for the parallel sides in a 3D shape. Now that we know that these are the bases, I need to find the area of one of those bases. And so the area formula is dependent on which shape you're looking at. So this is a triangle, and I know that the formula for area of a triangle is 1/2 base times height. And this is why we use H star in the formula for 3-dimensional shapes, because the symbol for H has already been used. It is the height of the triangle, which happens to be the base. So this does not get a star, this is a different H. Now I need to solve this problem so that I can plug it into my original problem. When I do that, I get 1/2, and then I need to plug in base and height. Remember, base and height of a triangle have to meet at a right angle. The base has to be one of the sides of the triangle, And the height can be one of the sides of the triangle, but it doesn't have to be. But what it does have to do is it has to meet that base at a right angle. So if I look right here, I can find that right angle on the triangle. And the base could be this 1.75 inches. And then the height would have to meet it at a right angle. And that would be this 2-inch side right here. So those are my base and height. They are interchangeable in this problem because they're both sides of the triangle. This is a right triangle. So 1/2 base times height, that's going to be 1.75 and 2. Going ahead to solve this, you could plug this in your calculator if you like, but I actually just see that these cancel out, leaving me with 1.75 as the answer. And that's what I'm going to go ahead and plug in right here for base. Next, I need H star. That is the height of the shape. The height of this shape is 4 inches. The reason that I know that for sure is, first of all, it has to, much like we were looking for things meeting at a right angle when we found the base and height of the triangle, it's similar to that in the 3D shape. The base of the triangle and the height have to meet at a right angle. In other words, it has to be the straight up and down height, not the slant height. The slant height right here is not used in this equation right now. We are looking right here at the height of the shape. Another way to think about height is if the prism is sitting on its base, which this one is, and it's sort of driving down the street, how tall does the bridge have to be in order for it to fit? Well, it would have to be 4 inches tall because it's sort of slanted down a little bit. It can fit under a 4-inch bridge. 5 inches would give it too much room. So that's not the right height. We're looking at the 4 inches. When we solve this, we just go ahead and multiply these together. 1.75 times 4 gives me 7. I'm going to go ahead and grab the units from the problem, and that is inches. And this is volume, so it'll be inches cubed. Okay, go ahead and take a look at number 1. Pause the video and start it when you're ready to see the answer. All right, let's take a look at number 1. We were finding the volume, so we used the formula capital B H star. And then when we plug that in, we were given the height that was given to us right in the problem. It's right here. It's the 7 inches. That's how high the prism is from base to base. It's the distance between the two parallel bases. And we need to also find the area of one of those bases, and that is it's a little hard to tell in the picture here, but this right angle lets me know that the base is actually a rectangle. And the formula for area of a rectangle is base times height. And actually, it's a specific rectangle. It's a square because all of these sides are congruent. So it's going to be 10 times 10, which gives me 100. Plugging that into the formula, we get 700 cubic inches for this one. All right, next we're going to be talking about pyramids. And before I do that, I want to talk about where the formula for surface area of a pyramid actually comes from. So looking at the pyramid here on the left, I'm going to go ahead and find the surface area sort of the long way. And to do that, you find the area of all of the sides and you add them up together. The pyramid is made up of a base, and then it has parts that are sort of going up and meeting at a point. And then I would add all of those together. So each of these sides is a triangle, and the area of a triangle is 1/2 base times height. Now, at this point, I can't just multiply by 4 because there's 4 of them, because these triangles are not guaranteed to be the same size. In fact, they're not marked in any way that they're congruent to each other, so I can't just multiply by 4. I can continue to add them up, but let's take a look and see why they're different. First of all, the H in the formula has to do with the H of the triangle, the height of the triangle. It is not the height of the pyramid. So height of the triangle is right here. And that's what it's referring to. that makes a right angle right there. So it's 1/2 times the base times the height of the triangle. And when it's talking about base, of course, it's talking about that base side of that particular triangle. All of the triangles have the same formula for area, but what they have that's different is they have different bases. The heights are the same. The slant height is the same for all of these. But what is different is the base. So this will be base 4. So now I just need to add these up. This is 1/2 base 1 times h, and then I will add the rest of these. So 1/2 base 2 times h plus 1/2 base 3 times h plus 1/2 times base 4 times h. So those are the 4 triangles. Then there's also the base at the bottom. In this case, it's a rectangle, but it could be any shape, any polygon. And the area of the base is given by capital B. I don't need 2 of them because there aren't 2 of them. A pyramid just has 1 base. Taking a look at these first 4 terms, you can tell that they're different by their base, but the 1/2 and the h is the same for all 4 terms. So I can actually go ahead and just factor out the 1/2 and the h. So this would be 1/2 times h. And if I pull that out of every single term, what I am left with is this. I would be left with a B1, a B2, a B3, and a B4. That's what would be left because I pulled out the 1/2 and the h. And then, of course, the plus area of the base would still be there. At this point, what you need to do is recognize that adding the bases together, adding B1 plus B2 plus B3 plus B4, is adding these 4 sides together. This one plus this one plus this one plus this one. We have another term for that, and that term is perimeter of the base. Adding up the sides of the base is called the perimeter of the base. So we are going to, instead of calling this B1 plus B2 plus B3 plus B4, we're going to call that perimeter. So surface area equals. That is going to be called the perimeter. The 1/2, that's going to stay there. And this little h for the h of the triangle, so that it's not confusing having all of these h's in the same problem, we're going to call this with a lowercase cursive l. And that is the symbol we use for slant height. So the slant height is this line here in red. And notice that it came from the area problem of the triangle. It's the height of the triangle, but it is the slant height, the slanted height of the pyramid. And then lastly, bring down the capital B. So this right here is the formula that we will use, and we'll put this in the notes in just a second. We will use that formula for surface area of a pyramid. So let me go ahead back to the notes so we can write that in. Rectangular or square pyramid, the formula for that, surface area equals 1/2 slant height times perimeter plus capital B, which means area of the base. All right, let's take a look at the part on the right here. I want to look at where the volume formula comes from for a pyramid. What I have on the top here is a rectangular prism. The bases are right here and right here. Those are the bases. And then I have a pyramid drawn here with the exact same size base. So that is the same. What else is the same? This has the same height as this. They're both the same height. But hopefully you notice that even though they have the same base, they have the same height, they clearly have different volumes. The pyramid volume is less than that of the prism. That's true. But it's not just sort of any amount less. It's a very particular amount less. The volume of a pyramid has a volume formula that is based on the formula for volume of a prism. So we do know that the volume of a prism is found by area of the base times h star. So this will be h star because it's the height of the 3D shape. The volume of the pyramid is going to be smaller. In fact, it's going to be 1/3 of that, which was the prism. So we can go back up into our notes and put that in. So the volume is equal to 1/3 the area of the base times h star. So now we've got two formulas here with a lot of different variables. So we should go ahead and label each of those variables in the picture so that we can remember which is which. So area of the base, I don't think we need to label because we have been dealing with area of the base for a while now. But something that's new is the idea of the slant height. So the slant height goes from the top of the triangle side, any of the triangle sides, doesn't matter which, I'll go ahead and draw it right here. It goes all the way to the base, and it does make a right angle. As you're going down this triangle, it makes a right angle. So that right there is called the slant height, and we use the cursive L, so I'll call it slant height. Oops. And then the line that's in the middle there, the red one, that makes a right angle inside of the shape. It's basically showing how tall the shape is. That is h star. That's h star. All right, let's take a look at example B. We're going to find the surface area and volume of this pyramid. And then I'll write that in since the directions don't say. So we're going to find the surface area and volume. And then we're also going to round to the 100th place because this will have some decimals. We need to know where to round that to. So let's go ahead and find surface area first. The formula that I'm going to use looks like this. Surface area is equal to 1/2 slant height perimeter plus area of the base. And then I need to find each of these things. So when I do that, surface area is equal to 1/2 slant height is the first variable that I get to. It's not given in the problem, so I'm going to need to find this. And the way this works is, let's zoom in on this picture. In the middle there is the height of the pyramid. It's in red. And if I go ahead and sort of trace over that and then maybe go this way and then maybe drop another line going right down the side of the pyramid, I get this little slice right here that it happens to be a right triangle. In fact, if I pull that little slice out, it's going to look something like this. And that's a right angle right there. Some of the numbers we actually have. In fact, they tell us the height, which is this vertical line here, is going to be 10. We don't know what this bottom is, but we do know that if it went all the way across, it would be 5, which means it's 2.5 because it's only going halfway across the bottom of this base. So what we have now is a right triangle that is missing its hypotenuse, and this hypotenuse happens to be the slant length or the slant height of the pyramid. So we can just use the Pythagorean theorem now to go ahead and find and solve for L, solve for cursive L. So that's going to be a squared plus b squared equals c squared. A is 2.5, b is 10, and c is actually the slant. So when I plug this into the calculator, I'll kind of do it all in one go. 2.5 squared plus 10 squared, that comes to 160 6.25. And then I'm going to take the square root of both, and that will tell me what the slant is. It is 10.31. So 10.31. Is the slant. So that's what goes in here. Next is perimeter. This is perimeter of the base. When I look at this, it's a square. Each side of the square has a length of 5. So the perimeter is just going to be those sides added together. You could also do 4 times 5 because they're all the same. But either way, I get 20. So that's going to get plugged in right there. And then lastly, I do need to find out what the area of the base is. So that again is a square, which means the formula is side squared. So when I plug in a 5, I get 25. So that's what gets plugged in for capital B. When I plug this in my calculator to solve this, I'm going to get, let's see, 1/2 times 10.31 times 20, get the answer for that, and then add 25. I get 128.1. And because this is a surface area problem, the unit will be units squared, so it's going to be square centimeters or centimeters squared. So that's the surface area. The other part of this problem is finding the volume. So I'm going to go ahead and scroll down to where I've got a little bit more room. The volume formula, remember, is very similar to that for the prism. It's going to be volume equals 1/3 base times H star. Filling this in, I don't know what the volume is, so that stays a V. The capital B we actually already solved. That's 25. That gets plugged in there. H star, remember, was actually given in the problem. It's this line going right down the middle, meeting a right angle at the base. So that's going to be 10. So when I plug that in and then plug it in my calculator, I get 83.33. And again, remember, I'm rounding to the nearest 100th. Volume equals 83.33. And the unit here is cubic centimeters. So that would be for volume. All right, go ahead and take a look at number 2. Give that one a try. Use the same directions, find the surface area and volume, and round it to the nearest 100th. Pause the video and start it back when you're ready. All right, taking a look at number 2. We have the surface area of 38.64 square inches and the volume of 10.67 cubic inches.